Hello students, this is Mr. Wolsey. For this video, you're going to need to take down notes on grid paper, just like you see here. Now, I'm going to begin this video by kind of prefacing it with what you've already studied. Now, in the previous chapter, you studied things called quadratic trinomials. Let me give you an example of a quadratic trinomial. Pretty simple one, x squared plus 2x minus 3. Okay. Now in the last chapter, you studied how to factor these things. Okay. So for example, if we were to factor this, it would look like this: x plus 3 times x minus 1. Okay. So this is what we did in the previous chapter. Now in this chapter, we are going to be studying quadratic trinomials again, but we're going to change it up a little bit. We are going to be studying things that look like this: y equals x squared plus 2x minus 3. Okay? Notice what we did here. We have a y equals now. Or sometimes we could also write it like this: f of x equals x squared plus 2x minus 3. So in this chapter, we are studying things called quadratic functions. And the only difference is that we now have an equation. Okay? Y, or f of x, equals a quadratic trinomial. Now I hope that your first thought, whenever you see something that looks like this, with a y and an x, I hope that you can realize that we can graph this. Okay? So that is going to be what we're going to be studying in this video. We're going to find a way to graph functions that look like this, quadratic functions. Okay? So the title of this video is officially Graphing Quadratic Functions. And let's just dive right into our first example. Our first example is going to be to graph y equals x squared plus 2x minus 3. Okay? So the first thing that we're going to need, of course, is a set of axes . And let's begin by graphing this function the old-fashioned way, using a table of values. Okay. So here's my table of values. Now, of course, I shouldn't need to tell you this, but you are taking notes with me as we go along. X and Y. Now, let's give a domain of, let's say, -4, -3, -2, -1, 0, 1, 2, 3, 4. So let's see what this function does in that domain. Okay. Now, in order to find the y values, of course, all we need to do is stick in -4 for x. Okay. Now, when we're typing this into the calculator, we need to be really careful. We need to wrap these negative numbers in parentheses whenever we square them. Okay? So let's do the first one. Parentheses, -4, get out of the parentheses, and square, plus 2 times, in parentheses, -4, and parentheses, minus 3. Positive 5. Okay? So when x is -4, y is positive 5. Let's quickly do the same exact thing for -3. -3 inside of parentheses, get out of the parentheses, square it, plus 2 times, in parentheses, -3 minus 3. 0. Okay? And so on. What I'm going to do is I'm going to cheat. I'm going to go to Doc, File, New, No, graph, I'm going to graph this quadratic function in my calculator, and then I'm going to create a table. Okay, so x squared plus 2x minus 3. Okay, so that's what our graph is eventually going to look like, but I'm going to require you to graph it exactly on a grid paper. Now let's make a table. I'm going to go to Menu, Table, Split Screen Table. Bam! Good. Now I'm going to scroll up a bit. -4, 5, -3, 0. That's what we've already got. Now let's just copy down the rest of this table. -2, -3, -1, -4, 0, -3, 1, 0, 2, 5, 3, 12, 4, 21. Okay, so there is my table of values. Now let's do our best to graph all of these points. Okay, and let's start to see the graph of this function emerge. So -4 up 5. Of course, this is the x-axis, this is the y-axis, which should always be labeled. -3, 0, so -3 up 0. -2 down 3. -1 down 4. Over left, right, 0, down 3. Over to the right 1, up, down 0. Over to the right 2, up 5. And yeah, that's too big. I'm not going to graph that. Right? But from here, you can kind of see the shape of this graph emerge. Right? It's kind of a bowl shape. Okay, so I'm going to just carefully connect these dots. Bam. I drew an arrow at the end because this graph keeps on going on and on and up. Whoa! Okay, well, I didn't hit those 2 points, but you get the idea. Alright, now let's highlight some key points on this graph. Let's start with the names of points that you're already pretty familiar with. So for example, this point right here. This is where the graph intersects the y-axis. And you've already encountered a name for that point right there. This is called the Y-intercept. In this particular case, the Y-intercept is, let's see, left, right, 0, -3. Okay. Notice that that point is right here. This is the Y-intercept. The Y-intercept is where x is 0. Okay. Now, another name of a point that you're familiar with is the X-intercept. Do you see where the X-intercepts are? Notice how I said that plural. There are 2 X-intercepts. Okay? There are 2 X-intercept. The ordered pair of that X-intercept is over 1 up 0. Notice that it's right here. And the ordered pair of that X-intercept is -3, 0. And notice that we can see it right here in the table of values. So there are 2 X-intercepts. Fast forward a bit. Look at these 2 numbers, -3 and +1. And then look back at the factored form of this quadratic trinomial, x plus 3, x minus 1. The fact that these numbers are related is very, very important. And that is going to be the topic of the next video that we watch. Now, coming back here, we have one last point that I want to highlight. This point right here, the very tip of this graph, is called the vertex. In this case, the ordered pair of the vertex is -1, -4. Notice that in this case, this graph kind of points upward, and the vertex is the lowest point on the graph. It's the minimum in this case. And let me just highlight the vertex here. This is the vertex in the table of values. Now there's just one last thing that I want to point out in this graph. Imagine that we have a vertical line passing through the vertex here. I'm going to draw a dashed line. Now, notice the points on either side of the line. So like these 2 points. This point on the right is 3 spaces to the right of the dashed line. This point is 3 spaces to the left. Okay? And that is true of these 2 points as well. Over to the right 2, over to the left 2. Over to the right 1, over to the left 1. So the shape of this graph, the shape of this parabola, is symmetric around this line. So we call this line the axis of symmetry. Right here. Alright, now I want you to flip to a new sheet of grid paper, and we're going to look at a second example, and this is going to be our last example. Let's say that we want to graph the quadratic function y equals x squared minus 6x plus 4. Okay. Now the first thing that I forgot to point out with the last example is that the general form of a quadratic function is y equals a times x squared plus b times x plus c. You should have already seen that before. Okay. In this particular case, a is invisible 1, b is negative 6, and c is 4. Okay? Now, in order to graph that quadratic function, it turns out that we need to know 3 points. We need to know 3 points on the graph, and that will uniquely and completely determine the graph of that function. Just like, as you already know, it takes 2 points to graph a line. In this case, it takes 3 points to graph a quadratic function. Now, the 3 special points that are probably the easiest to find and graph are, first of all, the vertex. So I will teach you a way to find the vertex of that function. Another easy point is the Y-intercept. And then finally, a reflected point. Okay? So our goal now is to identify what these 3 points are and then graph them. Okay? So first of all, let's start with the vertex. Now the x-coordinate of the vertex, turns out that we can identify that x-coordinate using a formula, a really simple formula. This is the formula. Negative b divided by 2 times a. This formula will always be true for any quadratic function. I want you to memorize that formula right there because you're going to be using it a lot. Now let's look at what that expression evaluates to with these particular values. Negative, in parentheses, negative 6, okay, so there's 2 negative signs there, divide by 2 times a is 1, invisible 1. Okay? Now, negative and negative make positive, so positive 6 divided by 2 is 3. Okay? So that was real easy. We found the x-coordinate of the vertex. It's 3. Now, how in the world do we find the y-coordinate of the vertex? Well, we know the value of x, so we just use the function to find the value of y, right? The y-coordinate is just 3 squared minus 6 times 3 plus 4. What does that evaluate to? Let's see, 3 squared is 9 minus 6 times 3 is 18 plus 4, negative 5. Okay? So it looks like the ordered pair of our vertex is 3, negative 5. Bam! We have 1 point on the graph. Let's look back at example number 1 to see if this equation still holds. So we're saying that the x-coordinate of the vertex is given by this magic formula that appears out of nowhere, negative b divided by 2 times a. Now in this example, of course, a is invisible 1 again, b is 2, and c is negative 3. So let's plug those into this formula. Negative 2 divided by 2 times invisible 1, well, this is just negative 1. And does that match with the x-coordinate of the vertex that we already found? Why, yes, it does. Look at that. Bam. We found that this was the vertex. That is the x-coordinate. Now let's try to identify the y-intercept. Now remember, the y-intercept is the point where the value of x is 0. Okay? So all we need to do is plug in 0 for x in both places. Okay? So the x-coordinate, of course, we know is 0. The y-coordinate, we find the same exact way that we did here, except x is 0. Hey, if 0 squared minus 6 times 0, well, there's zeros in both places, so that just goes away. So y is 4 when x is 0. Y-coordinate is 4. That's probably the easiest one to do, right? So the y-intercept is 0, 4. Now, let's graph these 2 points so far. Here's my y-axis. Here's my x-axis. All right. So the vertex is 3, negative 5. So over to the right 3, down 5. Here's our vertex. Now another point on the graph is 0, 4. So left, right, 0, up 4. That's our y-intercept. Okay, now let's quickly just label these points. This is the vertex, 3, negative 5. And when I ask you to graph these in your practice work, I want you to label all of the important points as well. So this is the y-intercept, 0, 4. All right. Now, we have 2 points. If we wanted to, we could make a line between them, but we want to make a nice curvy shape. Okay, so we need 3 points. How do we find the third point? Well, I hope that the name that I gave to this third point is a way to kind of get you thinking about how we're going to find what the third point is. Reflected point. Let's look back at what we drew over here. There is an invisible line called the axis of symmetry going through the vertex. Okay, so let's real quickly draw that invisible axis of symmetry through our new vertex and see where that leads us. Okay, so this again is our axis of symmetry. Now, going back to example 1, remember that we found that the parabola, the shape of this graph, is symmetric around that invisible line. That means that points are the same distance on either side of the line. Okay? So we're going to use that fact to identify what another point on the line is. Just like down here, the Y-intercept is 1 to the right, and there's a reflected point right here, which is 1 to the left of the axis of symmetry. So here, we know that the Y-intercept is 3 to the left. That must mean that there is a mirror image point 3 spaces to the right. And that right there is the reflected point. It is a reflected point. It's not the only one that we could make. Reflected point. The ordered pair of that point is over 6 up 4. Okay? Now, with these 2 points, we could draw a graph. Okay? Just kind of make a little shape like that, and then kind of like that. Whoosh. Okay? Now, of course, if we identified what additional points on this graph were, we could make this graph look a little bit prettier. And in fact, let me show you what the actual graph would look like. There would actually be a point right here, and there would be a point right here, and a point right here, and a point right here. Now, the only reason that I know that is because I know how quadratic functions work, and I know that this should actually be the shape. Okay? So, when you graph with just 3 points, your graph is not all that terribly accurate. So you might need to get additional points in order to draw it more accurately. Okay? So the red graph there is more accurate. But the black line gives a general idea of what the graph is doing, and so it's acceptable.